Linda Shear, que es una destacada investigadora internacional. Ella es directora del Centro de Estudios Internacionales de SRI International. Ha estudiado el fenómeno de la tecnología en la educación durante mucho tiempo y además lo ha hecho no solamente en su país natal, sino además en otros países, lo cual es muy interesante. Y su trabajo se relaciona con cómo podemos identificar y caracterizar nuevas prácticas pedagógicas relacionadas con el desarrollo de las competencias del siglo XXI. Eso es muy importante y está relacionado con lo que hacemos nosotros. Luego, la reciente implementación de la nueva prueba CIIE2012 va en esa dirección y por lo tanto creo que es muy interesante escuchar la experiencia que Linda tiene que compartir con nosotros.
Gracias, Patricio, y buen día a todos. Para comenzar, lo siento por mi español muy limitado. La voz en su cabeza habla mucho mejor que yo, entonces I will speak English. I come from SRI International is my company. You might know it better by our old name, which is Stanford Research Institute. We are now officially SRI International. It's kind of like Kentucky Fried Chicken turning to KFC. They gave up the fried, we gave up the Stanford. But it's the same organization, and within that, I work for a group called the Center for Technology and Learning. This group does research that is very grounded in the learning sciences with the goal of fundamentally improving education and maximizing the learning that we can provide. I've been asked to talk about learning technologies today. And I want to start with one reason that many countries are looking carefully at the implementation, the integration of learning technologies in education. I'll read the quotes out loud so that the voice in your head can translate. In the new world of work, unemployment is high, yet skilled and talented people are in short supply. There's very wide recognition around the world that the world and the workplace have been changing quickly, and there's now a mismatch between the job requirements that we see in this global economy and how we've traditionally prepared our students. This conference has talked a lot about education at a crossroads, and I would submit that this is an important crossroad that many countries are facing. It's still the same age-old question of what kind of future are we preparing our students for, and what proportion of our students are we preparing for that future. It's just that the future has changed. So now even the ways that we have traditionally prepared our privileged students need to change as well. And a lot of people think of technology as the solution to this problem, right? We're going to bring in computers and everything will change. I want to show you a couple of different quotes from, these are all associated with big one-to-one learning programs. So this is happening in many different countries and many different jurisdictions, and it's the equivalent of giving a laptop to every student between the ages of 12 and 14 across the country, or within an entire province or state. So these are big initiatives, and they often have very high goals, right? And people are really have high expectations for them. So for example, these are all quotations that are related to the policy, that are from policy drivers of these initiatives. So one is, technology is a way to a better education available to students, teachers, and their families. The classroom is now an interactive place connected to the world. So we're going to give students computers, and education will be transformed, right? Here's another one. I have great expectations from this deployment. I would only be really happy if the next Bill Gates is from this region. So we're going to give all our students computers, and they will become billionaires, right? These computers are fantastic. This is my favorite. This is actually from a research summary of a policy document in one of these countries. It is envisioned that through the introduction of personal computers for children, it will produce a digital wave that will bring a change in the value of life and be used widely so as to increase people's devotion to God. So we are going to give students computers, and they are going to get religion. This is fantastic. Computers are magical. What these people are saying is, if we take a classroom that's a traditional classroom, and we add computers, magic will happen and fantastic things will happen to the children, for the children, right? We hear that all the time. None of the three systems that I just talked about associated a very specific plan with what happens in that plus sign and the equal sign, right? It's just an expectation that wonderful things are going to happen if we put computers in the classroom. And I have to say, I disagree. If you ask me whether computers make better learning, I would have to say no, because computers on their own don't do that. It's not an automatic process, but it is a process that can happen if we design for it carefully. And it is also a process that requires ecosystems of support that allow it to happen. So I'm going to talk about these three things. I'm going to spend most of my time talking about a particular research study we did across countries that looks at 21st century teaching and learning in different places, and then across them. And then I'm going to spend some time unpacking this second point. What kinds of designs can computers suggest that really can help learning? Okay. So first, the study is called Innovative Teaching and Learning Research, or ITL Research. I want to thank Microsoft Partners in Learning for global sponsorship of this program in conjunction with partners around the world. It was a multi-year study that looked at the factors that promote the transformation of teaching practices. So this is the new ways of teaching and learning that we've been talking about at the conference all the last couple days, and the impact those changes have on students' 21st century skills. And we're looking in a broad range of countries. So we think of education as an ecosystem. Students' 21st century skills are in the middle, and I'll describe exactly what we mean by that in a moment. Those are shaped primarily by the teaching practices that they experience in the classroom. What's their experience of education? And that, in turn, is influenced by the supports at the school level and at the education system level. And this study looks at the interrelationships between these levels. Okay, so how do teaching practices influence student skills, and what are the influences on teaching practices that we need to be aware of in order to make this all work? Partner countries. This slide has 8 countries that we have worked with over the several years of the program. In each country we worked with a policy partner and also had the privilege of working with wonderful research partners in each of these places that were responsible for local implementation of the research. Yesterday, Andy Hargreaves described a set of high-performing countries and research that was based on that. This is not that, right? There's some overlap. We have Finland. Everybody has Finland. But what we were aiming for is diversity, right? We wanted a diverse set of countries to represent countries that are very mature at this kind of transformation of teaching and learning, and countries that are newer at it, to really see what's happening out there rather than only what's happening in the best places. So we looked at the national level, the school level, the classroom level, and the student level, focusing most specifically on what we're calling innovative teaching practices and students' 21st century competencies. So let me unpack that just a little bit. When we think about innovative teaching practices, the research breaks it down in some ways that'll probably be pretty familiar: student-centered pedagogy, learning beyond the classroom, and ICT integration. The point I want to make here is that ICT is last in this list, not first. We give them equal weight, but we don't think of it as a driver. We think of it as a facilitator and an enabler. Okay? So really important point. The point is not to use technology. The point is to support student-centered pedagogies, right? And when we think about student outcomes, 21st century competencies, knowledge building or knowledge construction, problem solving, innovation, collaboration. These are all very, very familiar words. We developed this list and then a lot of detail behind it based on a lot of frameworks for 21st century teaching and learning that are out there in the world, and then we added some stuff to it that I will talk about. So our methods, it was actually very important to us to have methods that allow us to understand each context deeply and also to speak across them, right? So we have quantitative and we have qualitative. The researchers in each country surveyed about 650 teachers per country. They visited a bunch of schools, so there was a lot going on with methods. Important to understand that the survey sample is not representative. So we can't say, I will not say Finland higher than Senegal, right? We can't compare countries, we don't want to do that. What we're looking for is what happens within each. I'm actually going to talk a little bit more about methods than I might otherwise because 21st century teaching and learning is something that a lot of people have been struggling to measure. So I want to tell you a little bit about how we do it. I want to apologize first for those of you that were in the room for the last session. My methods are nowhere near as cute as Lisa's, which I'm sad about. But the one here I want to unpack a little bit is this learning activities and student work because it might be less familiar. So what we did is actually collect samples of classroom activities, both from the teaching side and from the learning side, and let me describe that a little bit. The reason we did this, the reason we took this approach is that outcomes like problem solving and collaboration are very easy to talk about, and we all throw these words around a lot, but it's really hard to look and see how much it's happening, how deeply it's happening. We don't have a lot of ways of doing that. I know that you've developed an assessment here in Chile that is computer-based that looks at some of these things, which is fantastic. We couldn't do that easily across countries. This is a different approach that actually leverages what is really happening in classrooms. Okay, so we actually go into the classrooms and well, actually, we don't go into classrooms. We ask teachers to submit artifacts from the classroom. So we can do this without disrupting classroom practice, but still take a look inside. And we have a set of rubrics that I'll describe that provide specific measurements of progress. And this works in reliable ways across vastly different classroom settings. It can be across ages. It can be across types of classroom environments. So that's what this method is good at. So let me say a little bit about what we did. The researchers in every country collected samples of the learning activities that teachers assigned to students. So here's an example of a learning activity. It looks a lot like a lesson plan. It might be what's handed to the student, and it suggests their activities. So in this case, this is from Russia. Why should we remember World War II? And the students are doing some research with their relatives and they're writing an essay. So this is a pretty typical learning activity. And then the partners also collected samples of the student work that was submitted in response to that learning activity. So in a class, they picked 6 students at random and took the work of those 6 students. So we could also collect and look at that. Okay? So we have these samples. And then we recruited local educators to act as coders. So this is the job of local teachers that were not involved in the research to put codes on this. And they actually coded the samples with rubrics that were very, very specific with definitions of the skills that we hope the students will build. And the pictures you see are examples of these coding sessions happening in different countries. Like I said, it's not as cute. This is an example of a coding rubric that the teachers were given, and this is all supported by very specific definitions. So when we're thinking about collaboration, we're looking at a learning activity and we're seeing to what extent does it promote students' collaboration? To what extent does it require students to execute these skills, right? So the first step is what we often think of as collaboration, which is, are the students working together at all, right? But then we want to look deeper. and we say, do students have shared responsibility for their work, and are they making really important decisions together, which is when you get those important skills of listening to each other and negotiating and all those kinds of things that we really want to see, right? So what this rubric does is unpack the jargon of collaboration and really help teachers to understand what it looks like in practice. As we were doing these coding sessions, it turns out to be a very, very powerful opportunity for the teachers that are doing the coding to think about what 21st century teaching and learning looks like in practice. And we have actually taken this method into a professional development program that we call Leap 21. It's being piloted here in Chile. I'm not going to talk about it a lot today, but I'm happy to answer questions about it. So we look at a bunch of what we call dimensions of learning activities. To what extent do the learning activities ask the students to demonstrate these skills, and to what extent are they shown in the student work, right? And just a tiny bit about a survey measure that you'll be seeing a lot. We have this measure called the Innovative Teaching Practices Index. This comes from the teacher survey. We ask them how often they do things in these categories with their students. And we standardized in a couple different ways. We wanted to give equal weight to the different constructs. And we also standardized within a country so that a single country that's more advanced on these measures is not driving the entire analysis. So the thing to know about this measure, and you'll see it a lot, is simply that it's relative and it's within country, okay? And there's a lot to look across. We had a very, very diverse sample of countries. And this is just one example of how they're diverse. So this is the number of computers that are in a classroom, actually the number of computers per 100 students in the classroom. And as you can imagine, if you're in England and you have a computer for every 2 children, you have a very different set of opportunities and constraints than you do if you're in Senegal and you have a computer for every 50 children, right? So there are very different things that are called innovation in each of these different countries. I'm going to talk about some things that are in common across them. So this is a slightly difficult picture to interpret, so let me help you through it. This is from the learning activities and student work analysis that I talked about. So each of those dimensions that you saw, like collaboration, has a scale from 1 to 4 that it was coded depending on the depth, right? So this learning activity score is the average rating across several dimensions for a given learning activity, okay? And then the student work score is the average rating across dimensions of all the student work that was submitted for that learning activity. So we're pairing, this is what the students were asked to do and this is what they did, right? And the other thing to notice is the size of the bubble represents how many points there are. Okay, so 2 things to notice about this. One is that there's a very, very strong correlation in scores between the skills that we ask them to do and the skills that are demonstrated in the student work. So students are much more likely to do these things, to build knowledge, to use ICT in important ways, to learn how to solve real-world problems, if their assignments explicitly ask them to. It was much more rare that we saw assignments, that we saw student work that exceeded the level of the assignment. So there's a real ceiling effect. If we don't ask them to, it's unlikely that they will, right? The second thing to notice here is the size of the bubble at 1, 1. Now 1 on each of these dimensions means it's not happening at all. The assignment is not asking the students to build any knowledge. It's asking them to learn something, right, but it's not asking them to do active construction of knowledge. It's not asking them to use ICT. It's not asking them to solve any real-world problems. And the preponderance of these activities were at that level. So in the countries that we were in, we actually looked for good examples of innovative teaching. And this is how much we found it, right? So across countries, there is still a very, very strong preponderance of very traditional instruction going on in schools. So switching to survey data here, we're looking at the distribution of innovative teaching scores, either across teachers within a school or across schools. And what this is saying is that there's a whole lot more variation across teachers than there is on average across schools. Statistically, this is not that surprising because the average for a school is a more stable measure, but it's corroborated by a lot of qualitative evidence that says when we looked at these schools that were nominated actually for innovative teaching, what we really found is a couple of teachers that were out there choosing to be innovative and doing it on their own rather than, on average, a school where those practices were prevalent. So the question that leads us to is, when are those teaching practices most likely to flourish? When are we most likely to see this stuff? So I'll show you a few results about that. And let me describe how to read this graph. So this is on the topic of whether teachers collaborate about teaching practices. And what you'll see in this whole next series, this Innovative Teaching Practices Index, as I told you, is a relative measure. On this x-axis, we group teachers from the survey according to whether they reported that they do a lot of collaboration with teachers about learning, whether they do a little bit of collaboration with teachers about learning. So we lined them all up in a row according to that measure, and we took the bottom third, the middle third, and the top third, and we looked at the relationship of that with this Innovative Teaching Practices Index. And that, again, this is within country, and it can help us see what factors tend to be associated with innovative teaching. So collaboration is very strongly associated here. This is not causal. But again, we have qualitative evidence that talks a lot about the social capital and a lot of the other issues that we've heard talk about at the conference. So collaboration looks like it's important. Teacher appraisals that have something to do with this new teaching practice. This is kind of a stand-in for a lot of school culture kinds of measures that can encourage these practices or not. This won't be any surprise. Professional development, the characteristics of that professional development matter. So what this slide says is that any professional development is better than no professional development, right? But listening to a lecture is not going to move teaching practices anywhere near as strongly as professional development that's a lot more active. So practicing a new teaching method, conducting research on it, some of the ways that I know we're all designing for has a lot more effect on helping teachers to adopt these practices. Another thing that is that's fairly common is in these different schools that we looked at, typically innovative instruction was given much more commonly to students that are ahead academically or on path academically rather than behind academically. This is something we see a lot with innovation. Interestingly, in England, they were an outlier here, and they had the opposite pattern. And what we saw there is that the teachers that are in schools that are getting very low test scores had nothing to lose, and they really wanted to try pretty much anything to get their test scores up. So they were a lot more willing to take risks, as opposed to teachers that are in schools that already had high test scores that had something that worked, right? But that's not usually what we saw. Much more common to see innovation in humanities subjects than in something as structured as mathematics. Science actually varied. And one of the things that, actually the thing that teachers most commonly reported as a barrier, why aren't you doing this, is not enough computers for students. It's interesting that this result is, like the others, consistent across countries. Regardless of how many computers the students already have. And what we found is that when there were high concentrations of computers, when students actually had a lot of them, the teachers recognized the value and they wanted more, right? And we looked at the types of ICT use that was common. This is a frequency scale, so how much is this happening in your classroom? And what we saw is that finding information on the internet is the very most common thing in these schools that students are doing with computers. Practicing routine skills and procedures is very common. Turning in homework is pretty common. These are not the most powerful, game-changing uses of technology. So this is supporting that often when computers go into classrooms, they aren't magic. They're being used to support the practices that are already happening, and what we're calling high-level applications that are really doing the analysis, changing the way you think about information in the classroom, collaborating with peers. Those sorts of things don't happen as often in their natural state, right? And then at the system level, when we look at the constellations of things that are often an effect on teachers, so we look at national goals, we look at the supports that teachers receive to teach in these new ways, we look at assessment systems, we look at regulatory structures, and we look at incentives for teachers. Across countries, actually in most of the schools and in all of the systems that we looked at, there were really strong disconnects between these, and teachers felt really strong tensions between how their success is judged by parental choice, by an external examiner, and what the parents want, what children want, is not necessarily what this teacher thinks of as innovative instruction or as the most effective instruction. As opposed to a particular school in Russia that, because it had really strong scores on traditional measures, it was given a lot more freedom, and the teachers could select their practices a lot more, and the school leader had a lot more leeway to encourage those practices. What one of the teachers said is, in this school, it's just awkward not to use innovations, right? So what is this bias? A couple of reflections about this. The transformation of teaching and learning doesn't happen by magic. We're not seeing it organically happen in a lot of these settings, certainly not as quickly as we would like. But it can happen by design, with careful design. Innovation flourishes in an ecosystem that supports it. And finally, the learning activities that students are doing are more important than the high-tech devices they're doing them with. So it's not the glitter of the technology that counts, it's what we ask the students to do with the technology that counts. And I want to spend the rest of my time talking about this question of how can ICT support deeper learning? If that's why we're bringing it into the classroom, how do we design it in ways that are going to support that? I showed you how we code for collaboration. This is how we code for ICT in learning. And you'll notice that on this chart, nowhere does it say students use flashy colors, which we often think of when we look at a PowerPoint that students did. We're looking at the opportunity that ICT gives the students to build deeper knowledge, to really do active knowledge construction, and we're looking at the question of whether it has to be ICT. Is this something we were always doing, or is ICT offering us a new opportunity to do something different? And I want to show you just a couple of examples of ways that ICT really can enable a different sort of learning if we try hard enough, right? This is my list of top 7. This is not comprehensive, but it comes pretty close. These are a lot of the main things that ICT is really good at doing that can transform teaching and learning. And I'll talk about each one of these as we go. So the first is dynamic representations. So this is a program called Cornerstone Math, and it's aimed at the important math topic of rate, which is typically very, very difficult for children to understand. It's really a gatekeeper in a lot of early math. It's really hard for students to conceptualize what acceleration looks like on a graph. That's a really tough thing. What this does is it allows them several different dynamic representations at once. So they can see the student running, and they can see how fast that's happening. They can see it on the graph, and they can see it on a chart, and then they can manipulate these things. So they can say, if we want this student to pass this other student, what do we need to do, either on the table or on the graph, to make that happen, right? So they're actively engaging with these images instead of just having them be theoretical, right? This can be really powerful. Supports for rich collaboration. I want to recognize Miguel Nussbaum, from whom I shamelessly stole this picture from one of his videos. But Miguel is a researcher that engages in the very important program of computer-supported collaborative learning. There's a large body of research around that, looking at how technology can support an interpersonal network. So it's not about the students using the technology, it's about the students' interactions that the technology can afford. So there's a lot of thinking about how to construct activities, for example, so that everyone has to collaborate. Nobody gets to sit back and let their teammates do all the work, which we've always seen in classrooms a million times, right? How do we construct activities to make sure that they're all engaging? And everyone has to be successful for the team to be successful. There are a lot of ways that technology can support that. They might be doing something that's similar to the example that Hyman gave us yesterday, if you went to his talk, of if you're dividing 5/6 by 1/3, if we're doing fractions, there are a lot of different ways to represent that. And students on a team might be asked to give different representation, and the team doesn't succeed until they all found a different way to do that. Or it could be that every student on the team is responsible for moving a couple of pieces of shape, and they have to together create a shape that is defined by an equation, right? There's no way that one student could do it themselves, because each device only controls so much. And there's no way that the team will be able to do it if somebody isn't participating. So the important thing here is how the design of the learning activity shapes what the students are doing. So that's the very important focus of this wide body of research. New types of information resources. I wish I had 100 pesos for every time I have seen in a classroom students looking up information on the internet in ways that it totally doesn't matter that it's the internet. And it doesn't change anything they're doing. One of my favorites is a teacher that gave their students an assignment to look at a website and to find 3 facts on that website. And that was the entire assignment. This doesn't change teaching and learning, right? The internet itself does not change teaching and learning, but there are some things about it, ways that we can use it and ways that do. So genetically modified foods, enormous issue, very, very important. And students might be asked to find not only presentations of the risks, but also presentations of why it's a good thing. So this is a Monsanto site. You probably can't see this, but it says, opponents of genetically modified crops often describe them as untested and unsafe. This is simply untrue. And then it goes on to explain why. So students in this situation are enabled to do new kinds of analysis that the comparing and contrasting of primary sources allows us to do. And this might be a situation like this. It might be 2 sides of a war. There are so many different things we can do with this. And it also requires the evaluation of source credibility. So we're not using websites just as if they're a textbook, and we're trusting everything that's in them, right? But we're actually learning how to be, helping students to be savvy consumers. Other things that fit in this category of new types of resources, we can use a database of earthquake records over time or in different places that is authentic data as opposed to a table of earthquake records that the teacher made up for the purposes of this assignment, right? We're bringing new sources, much richer sources of information into the classroom for analysis. It's fair to say that in America we're pretty excited right now because we just put a rover on the moon, and the next day images from that rover were being beamed down into classrooms all over, and that's data that we never would have had in textbooks. So the internet can give us new ways of learning if we use it that way, right? Ability to interact with things that are very small. I'm actually deliberately using some examples here that are a little bit less sparkly because that's not where I want to focus. I want to ask you to think about what the kind of learning that this enables. This is from a program that that was carried out at SRI. It's called ChemSense, and this was developed between 2001 and 2003. So this is eons old in computer time, but it still does some really important things. In this particular case, it allows animations by teachers or students that explore and illustrate chemical processes that are not visible to the naked eye. So in this case, the students actually did an animation that this is part of. Molecular structure and how molecules interact is something that we always did with balls and sticks before in chemistry class, right? But computers allow you to take it a lot further, and what the students are doing here is they have a graph that shows the temperature, and as the temperature proceeds, they're illustrating what's happening to the molecular structures, and as they're doing that, they're writing an explanation. So in this case it says, as ice gains energy, its structure wiggles. And later they'll talk about how the structures break apart as it switches phases. They're having to put together all their understanding and making this very concrete and making it something that they can work with, which is not usually true of atomic structure. And in doing so, they have to figure out things like, what should the angle be between these atoms? So they're both developing and demonstrating their understanding through this process. So that's things that are very small. There are also things that are too large to really understand through the naked eye. And usually detailed real-time views of the night sky is not something you can explore from within a classroom unless you have the opportunity to remote control a telescope through the internet on the other side of the world. So in this particular case, this is in the US state of Virginia, which is in the same time zone that you are. And students have access to a telescope in Pengali in Western Australia. So when it's 11 o'clock in the morning here, the students are actually able to manipulate this, these images of the night sky, and they're able to decide what they want to research, grab images, be affected by the same things that real scientists are affected by, like dust at harvest time, right? So they're getting to experience this in the classroom. You couldn't do that before, right? Feedback on learning for students is something that that we often see, so formative input in a lot of ways. This is a program called Assessments out of Worcester Polytechnic Institute, and what it's doing is walking students through some pretty common problems that we'll often see. So this is looking at congruence of different triangles. The students gave so it's, the triangles below are congruent. The perimeter of triangle ABC is 23 inches. What's the length of side DF? And the students said 23, which is actually not quite right. So the computer comes back, and instead of letting them do an entire problem set with this misconception, the student is the computer is walking them through some ways to break it down and think about it. So it's going through a process of what does perimeter mean, and how are you thinking about this? So formative assessment is something that very frequently is done through computers, and it also gives information to the teachers that collects across the class. So this screen, for example, can tell the teacher, sorry, that's not a great image, you probably can't see it, but what it's telling the teacher is where each student is, but also what the most common misconceptions are in the class. What are the most common wrong answers? So that's something that teachers can directly use to as input to their instruction. These examples happen to be individual. It's individual feedback for the student. It's individual feedback for the teacher. You often see applications that that collect all the information aggregated into a single image, and then show that for discussion at a class level. Okay. Expanding boundaries beyond the classroom, there are a million ways to do it. This is a site that's called ThinkQuest. This is developed by the Oracle Education Foundation. It is a protected environment, so only students and teachers can have access to it. And it facilitates project work that is across classrooms and across countries. And students actually work together in these very close project teams to create important projects on things that they think are important. In this particular case, this is students from Singapore and China. So that's one way you can look beyond the classroom. There are also a lot of resources that you can look at. So, so museum websites that have collections up, or news organizations from different places. Again, these are resources that you probably wouldn't otherwise have in the classroom, and there are also opportunities to produce outside the classroom and give your work a different level of authenticity. Okay, so that's sort of that's a quick picture of some of the ways that computers really can transform teaching and learning. But it's important to recognize that individual applications aren't enough. We don't just think of this one application in math or this one application in history. It's really important to think about it as a system. And we think of it in terms of a curricular activity system. And what I mean by that, when we say curricular, it's really important that computers aren't just used as an add-on, which they often are, right? But we want to think about in our curriculum, what are the most important topics for students to understand more deeply, and start there. When we think about activity, you'll notice that all of the examples I gave of student learning through technology, they were very actively engaged in that learning. So it's not enough to just think about the lesson plan and think about the plan for what's going on that's external to the student. We really want to think about how we enable students to engage in activities that are really deep exploration and building of learning. And then when we say system, this is the alignment of professional development and goals and curriculum and assessments and everything it takes to build that ecosystem where these practices can be taken on. So I want to end with a story. This is not something that happened to me. This was a colleague of mine in another organization, but it is a real person. This colleague was working in a country that is far from Chile, helping them to do a major technology implementation. And she went to her funder and asked for support for developing a learning plan to guide that technology implementation so that it would have more of the characteristics of what we just talked about. And the funder turned her down, and this is what she was told. This is technology. It's not about learning. And I would suggest to you that if we don't have a plan that connects what technology can do in a classroom, why we're trying to do it, and how we're going to get there, the specific types of learning that it's going to afford, and a plan that sets up a system of all the supports that the teacher needs in order to translate that vision into classroom practice, then this statement is at great risk of coming true. And I'll end there. Thank you.
Thank you, Linda. You're perfectly on time.
En una aula piramidal donde hay un profesor adelante y alumnos escuchando, sino que se transforma hoy día el aula en un círculo, en una mesa redonda donde los alumnos ya son participantes interactivos de la formación educativa, donde los docentes nos sorprendemos con la información que cada uno de ellos nos expone y nos sobrepasan. Es evidente, la suma de todo ello es más que lo que yo puedo aportar. Por lo tanto, el desafío que yo creo que tenemos por delante, y esa es una etapa muy relevante en todos los países y a nivel mundial, es en tan grande fuente de información y tan dispersa, ¿cómo nosotros podemos tener una entidad o un organismo que de alguna manera oriente en toda esta dispersidad de información cuáles son los caminos para poder nosotros entrar a investigar y llevar a nuestros niños de acuerdo a los currículos de cada país, y ya a la vez cómo nosotros podemos implementar en todos los países, en este país, un currículum en el cual las TIC pasen a ser parte no solamente como una materia, sino que transversalmente en la formación de los futuros educandos. Esa es mi pregunta.
Gracias. Siguiente pregunta, por favor.
First of all, thank you very much for your presentation. My doubt is the following. How can we manage technology during our class in order to avoid students to get distracted and to visit other websites that do not have anything to do with the class? That's a usual problem teachers deal with.
Y la última para este primer bloque de preguntas.
Una generación que recuperar no comprende esta última frase que es clarísima. Esto es tecnología. La educación la tenemos que poner nosotros. ¿Hay alguna experiencia importante que nos pudiese aportar en estas líneas?
Ok. Demos la oportunidad a Linda de contestar.
Thank you. These are great questions. So the first question is, there's so much information that's out there, there's so many resources, how do we make use of it? How do we figure out what to do? And I think that's very tied to the third question, which is, how do we train the teachers to do these things well, right? So one has to do with the provision of resources, and I think there are a number of there are a lot of educational portals and that kind of thing that teachers can go to for particular resources on particular topics. So those types of things are proliferating. I think the bigger issue is how to train the teachers to understand how to bring these things into the classroom. And as someone said, that's a particularly important issue because a lot of these teachers are not very savvy about using these resources themselves. And issues of not trusting the information on the internet immediately. Not all teachers are very savvy about those issues to start with. So it's something that we need to do a much better job of building into teacher preparation from the beginning, right? And to teacher preparation programs before they get into the classroom to really experience these things. And, you know, based on what we know about teacher training, the important thing is that teachers aren't just learning about these things theoretically, but they're experiencing it in their own learning in their programs, right? And they're using these resources in the ways that we would want them to ask their students to use the resources. So we can teach teachers to be discriminating about these things from the beginning, and that can happen both in pre-service education and also in in-service education. I mentioned this LEAP 21 program that really helps teachers to look at all the skills they're trying to get students to build and think about the extent to which their learning activities are promoting those skills. So there are things we can do that help open eyes around that as well. And then the second question was, is a super common one, which is how to manage ICT to avoid student distractions. You know, there are many, many places in America and in a lot of countries where students are not allowed to bring their devices to class because they're seen much more as a distraction than as an enabler. And in one of the one-to-one programs I described at the beginning, there was actually, in a province, students were being given mobile computers, and there was a national law that said that students would not be allowed to bring computers into the school. So this province had to get a rider on that national law to even enable it. It is really true that if students are unguided and they have access to these things, they'll be sending texts and they'll be doing all the things that students do, right? The key is to keep them very engaged. If they are doing one of those collaborative activities that requires the activity of every student, it's a lot harder for them to be off surfing the internet in ways that are not supportive. It's much easier to be distracted when you're being asked to sit and listen to the teacher, right? So make them active in ways that really target learning activities, and that's what they'll do. Right.
Thank you, Linda. ¿Más preguntas? ¿Allá? La dama del micrófono. La perdimos. ¿Se nos fue? Ah, ya viene. Mientras tanto, ¿alguien más?
Es que no alcanzamos.
No, no hay más preguntas, pero si quedan 5 minutos. Allá hay otra.
¿Aló?
Ya.
Mira, yo tuve un gran profesor Magenzo, de la Universidad Católica. Yo estudié Pedagogía Castellano, y cuando se hablaba mucho de los recursos para la educación, él siempre decía, un buen profesor no necesita grandes recursos, incluso puedes educar en el campo, con piedras, con ramas, etcétera, ¿ya? Lo que yo quisiera preguntarte, porque cada vez que tú ibas enunciando los aportes de las TIC a la educación, que es lo fundamental de este tema, yo iba comparando con un buen profesor sin las TIC, ¿ya? Entonces, la pregunta apunta a lo siguiente: ¿cuál crees tú de todo lo que dijiste piensas que es lo fundamental, el fundamental aporte en términos de habilidades para los alumnos, ¿ya? De las TIC? Porque uno podría ir, como te digo, haciendo el paralelo, decir, bueno, pero yo esto lo puedo hacer así. Por ejemplo, en términos de acceso, yo creo que la gran ventaja de las TIC tiene que ver con el acceso a la información, la rapidez de la información, la cantidad de información, pero eso no genera habilidades en los alumnos necesariamente tal como tú lo planteabas. Entonces, lo que yo quisiera preguntarte, claro, porque aquí media el tema del profesorado. Es el profesor, como tú bien decías, el que apoya, te fijas, el que tiene que orientar, como decía también un profesor acá, pero la pregunta es, ¿cuál dirías tú que es el aprendizaje, la habilidad esencial que aporta la TIC al alumno?
Ya. Y la última pregunta que queda pendiente por allá.
Bueno, gracias.
Allá, allá.
Como sabemos, muchos de los métodos que se usan actualmente llevan años formándose, preparándose, usándose por muchos docentes, y por ende hay de repente recelo al cambio de estos métodos, en el sentido de no han preparado sus materiales durante años y se encuentran frente a nuevas generaciones que buscan mejorarlas, cambiarlas, y de repente hay una especie de duda frente a eso, quizás casi negación. ¿Cómo pueden modificar mis métodos que llevan dando resultados durante tantos años? Entonces mi duda es si actualmente o al futuro el cambio generacional que se va a dar en los próximos, no sé, 30 años, cuando los profesores que están actualmente, o 30, 40, 50 años, los profesores que están arraigados en estos métodos que han sido efectivos, cambian por las personas, los docentes que están recién saliendo. ese va a ser un cambio significativo y va a ser como un peldaño más en este avance integral las tecnologías, ya que toda esta gente va a llegar con las tecnologías como parte de uno. Yo no sé si va a ser el cambio generacional, va a ser un gran cambio, o va a ser simplemente la adaptación del actual aprendizaje por la integración de la tecnología.
Con eso concluimos.
Bueno, gracias. Again, great question. So the first question was, a great teacher does not need great resources. Because teachers have been, the things that I illustrated, good teachers have been doing for a very long time. So it's not necessarily, it's not saying that good, solid teaching doesn't accomplish a lot of what we need to accomplish, but it can deepen it significantly, and it can also make learning more consistent with what students are doing in the outside world, right? Because these ideas of discriminating across information that they find out there and working through technology with peers and with other people, and really thinking deeply about analysis of real-world issues. Those are things that students are needing to do in the outside world a whole lot more. And so it's enabling those kinds of things. I would never say that a good teacher wasn't able to promote opportunities like that before, but I think that technology can support a lot more and a lot deeper opportunities for that kind of work in ways that are more consistent with the ways that you and I use information all the time now, right? And the other question was that teachers are used to their current methods, and for a lot of teachers, what they're doing is working. So do we have to wait for a new generation of teachers to learn these new things? And you know, what we've seen in a lot of the schools that we've studied is that the ones that have the most successful programs don't require it of all teachers at the start. Because in any place, you're going to have teachers that are very excited about this, and you're going to have teachers that don't see the value yet or don't think it's something that they can do yet, right? So the places where it's really worked have been opt-in strategies where resources and opportunities are given to the teachers that are ready for it, and those teachers can demonstrate the power when some of the more reluctant teachers look at what's happening in another classroom and say, wow, that was pretty exciting, let me try it. That's when you start to get groundswell, right? So it's not saying everybody has to teach this way now, but it's saying, let's get it started and let's plant the seeds and let's establish an ecosystem within which this can grow, right?
Thank you so much, Linda.
Muchas gracias.